Now I'm presenting the MES Infra Integrated Total Solution. The short form is MES, MITS features. As an introduction, I need to discuss about, or we need to know what is integrated total solution. So I think this picture, I think mostly you know also, I think most of you also Esteem user. This is the latest Esteem 8. So you can see, this is a really simple structure with a 2 key plank. So we need to do the slack first, and then transfer the slack load into the beam. Combine these 2 beam reagents coming down. Then this one design this beam, taking this loading, analyze, go to this column, go to the pocket. So this is, in fact, it's not a new thing. We implement this idea of the total solution since 1994. Actually, it's 17 years we start this concept. So at the time, it's I think what we know is commercialized, it's Esteem software we start first. So we actually gather all the experience, 17 year experience. Now, actually we implement this idea to our infrastructure applications. Okay, actually, to analyze the beam, we have a beam software, individual beam modules. Column also got modules. Slab, we also have modules. Pocket also has the modules. But the problem is, whatever outdates to the slab, you will not automatically update your pocket because it's all run by individual software. Actually, engineers need to do a lot of transfer work. So later on my slide, you can see a lot of transfer, the words are transferred. This means you need to transfer the information from beam to column to other, transfer column to the beam to the column to the pocket. A lot of transfer. If you got outdates in a loading here, once again you need to transfer until here. Many times repeated. You know, architect always change. So actually, to do the transfer, the job is very simple. Anybody can do. You can ask your a student to help you to transfer, because it's just a method of transfer data from one place to another place. But it is very time consuming because a lot of points you need to do. You need to consider some more. If you have to 100 or 10,000 transfer, if you got error 0.5%, you know you will incur how many error inside. This is the manual factor. So, just for example, I don't know, you calculate the nodes. Normally you take the money from bank, you calculate the nodes. I estimate myself, I only can calculate the 1 hour, 3,600 seconds. I only can calculate 72,000 nodes. So let's say you have 50 ringgit. 50 ringgit nodes. You calculate for 1 hour. You know how much money you can count? Actually, it's 360,000. That means if you have 1 million, 1 million amount of money with the 50 ringgit notes, you need to take 3 hours to calculate, to count the money. That is a very time consuming, but the work is very easy. Everybody can do that. And then, after you calculate finish, not tally. What to do? Recalculate again. So same thing, this is what the problem in our engineering during our design work. So that's why now all the bank, the banking, you seldom see a lot of people still counting money there. Use the ATM, you can cash out, they automatically calculate for you, because this is a job not supposed handled by human. If the computer, if the machine can do for you, you leave it to do, because they do it fast and accurate. And then also, like this time, even when we had checking, even using the software, we do the total loading, compare with the total output reagent must be tallied. If not tallied, we can find back. This is the checking. But imagine if you do it manually, you calculate, finish already, you find that total loading is not equal to the reagent. Then you need to check that one, recalculate again, repeat and repeat. This is the problem in the software without the integrated total solution. So in our MES infra application, we have a lot of modules. Individual modules, like earthworks 3D, they can do the earthwork 3D for you. And then if you have sewerage, each one they can do perfectly for you. But we still need the integration work. So that's why we can able to come up the MES to handle this problem. I think later on we will do the presentation, demo presentation on the MES. Okay, so we need to understand the modules first of all. This is a MES road, also is our new program. It's a MES road and highway. And then we do the roads and highway analysis, import from surveyor, drawing, horizontal alignment, and vertical alignment, road width design. So second modules actually is a earthwork 3D. So earthwork 3D can do the computation for the earthwork analysis, import from surveyor, auto interpolation, DTM and grid methods. Later on I will highlight this DTM and grid method. DTM is a digital terrain method. It's like those we so-called it's like FEM. Auto slot and burn generation, 3D contour, view and a 3D platform, elevation view. And then we have a long section, cut and fill, volume, quantity and... Okay, earthworks volume computation. We have grid methods and DTM methods. I missed out one piece of paper. Okay, so this is a two picture representing, one is a grid methods and the other one is a DTM method using triangular irregular networks. So grid methods is simple. Actually, it's very easy to understand. You have some information like contour line with the level 88 meter to 94. So actually, what we do is we make it a grid, then do the interpolation. Then we can, like this one, 90 here, 89. Of course, we know what after the interpolation, we know what is the nodes. Then they only have information at the grid intersection. So this is the formula, simple formula to calculate the volume difference. And then after we get this information, if you want to resample back, you want to draw back, actually it's like this. The surface is not original surface already. You see, it's like even the big size of grid and smaller size, there's a difference. This one more real, more like real surface. This one is already not original. So this is the problem. It's in the grid, using the grid method. Okay, then another problem is let's say if you are using a grid method. Okay, so let's say this part, this grid, let's say halfway you do the sudden drop, maybe it's for the retaining wall or platform drop. So like this one we have problem. So in the grid method, they won't capture this kind of drop because they will plot the line from here to here. From this information to another information, here to here. In terms of volume, they will say is cut and fill all are zero because the volume is different. They're using this part triangular here to compensate this one. So total out is neutral, become neutralized, no volume change. But they cannot say contractor know what to do. Contractor still need to cut the top part to fill here. So this is a cannot capture. So, but this one all can be captured nicely, accurately in the DTM method. And then this one also, let's say your surface is inclined like that. Then if your platform is flat, also, eventually, if you're using the grid method, you will say cut volume, fill volume is zero. This means no action taken, no cut and fill activities. But in fact, actually yes, because the upper one to compensate the lower one. And then some more, if you have a grid, big grid like this, let's say a 10 meter, this is a blind zone. If you excavate here or whatever, they also say no activities because cannot catch it, it's a blind zone. So the DTN, this actually we are using what we so-called using the information, then we link out using the triangular matching. This is some of the actually now all the software from overseas they all have this DTN method. You see, surface is very real. Whatever information recessed down, they all can plot nicely. You see, a very complicated one. You can see the surface, this one and this one, same shape. You won't say change topography to become flat, like that. So this is come up from our EW3D. It's area of view is a different color. So this is also a part of output from DTN method. Okay, so actually we can convert it to the line, translate it to the line to plot like contour. And this is output. And then this is a plan view, cut and fill areas in different color. And then this one is what we call it's a super 3D. We can see everything, topography plus platform. Later on we will do the detailed demo on this one. Okay, let's say just now my example. This is example using our DTN method. So you will get the correct answer. This means it's a cut 31.25, fill 31.25. Even the import export is 0, but still we have the cut and fill activities. Okay, so now I want to do some short conclusions. If someone say using a grid method, if you are 20 years ago, that can be excused because that time we had no technology. That time is actually our machine is a DOS, and then even Windows, maybe say Windows 3.1. And maybe I'm quite surprising. Maybe some software supplier they tell you, oh, grid method is better. DTN cannot be used because that is complicated, or garbage in, garbage out. And then for me, it's quite surprised because our user, we have many, as this morning, half of you maybe is our user. 99% they can choose between grid and DTN method by just pressing one button. But 99%, almost all, they will choose DTN method. And then if some software supplier they say that grid is better, you should ask him, do you have DTN method? If the answer is yes, then you can continue to listen, to study with them why they say grid method is good. But if the answer is no, if they only have a grid method, they don't have DTN method, I advise you not need to spend time to further discuss, because since they don't have, of course, they may say no good. As a software developer, as we are the software developer, let's say now a day if you don't have even the structural, you don't have analysis, you don't have finite element, or if you do the EW words, you don't have DTN method, I can take the conclusion as a software developer, actually the technology you are using actually is behind 10 to 20 years. 10 to 20 years. And then to do this DTN or finite element, actually we need to have invest a lot of money to buy a very good tools, technology. Not only that, you need to have expert to utilize that technology. You have money to spend, you can buy the technology tools. If you don't have expert to implement it, also no use. And then as a developer, software developer, normally the software limitation it should not be limited by the